All right. This morning's thought workout, I was just contemplating, well, uh, the works of Donald Williamson, who had some theories about the origin of larvae and how, by means of hybridogenesis, the larva came about, and uh, just different things that have to do with possibilities in development of animals um, and so I've always found it curious that large animals that they're according to the theory that I'm developing, which is on a page, paracatafungogenesis, uh, that the act of parasitism often causes the mass of an animal to increase in size or gigantism in some way. And my favorite animal with that is the pagonophores in the deep sea vents that have to get 10 feet long when they're larval state, where they have a gut and a lot of organs that occur naturally in other worms. Once they're infested with the deep sea thermal bacteria, all those organs deconstruct. There's tissue modification, and you get the thing becomes gigantic. It has no more gut. The thing then grows to like 10 feet long. When in its state of non-infestation, it would probably maybe, from what I remember, only it would be much smaller than 10 feet, but it would might even be in the inches size. But anyway, then I got to thinking about ligers, and ligers as a hybrid animal between lions and tigers, and looked up the information. Are there any fertile ligers? It turns out yes. You have the females are fertile, the males can be sterile. Um, but it just strikes me that they are categorized as the largest cat in the world. They 1,000 pounds, where both parents are 600 and 500 pounds respectively. Um, so effectively doubling the largest parent in one generation in terms of the size. All right, so then looking that up, there was something called heterosis, which is this effect that you get sometimes if it's not some detrimental or fatal genetic defect that causes the animal to die off young or shrivel, as if it's a spectrum that goes either it's going to go one way where it's bad or the other way where it's just super fit in the sense of largeness, if we're going to take largeness as a basis for fitness, right? All right, so anyway, so if we have fertile ligers, 1,000 pounds, one generation, and we let it go, and somehow or other we were to find another parallel to the liger that is 1,000 pounds, right? Uh, or make it the same, offset. He's 900 pounds of the liger and whatever other uh, creature would have to be obviously a cat, etc. And then we were to do the same experiment again. Now, would it be a genetic effect that doesn't stop, for that generation? So, looking at it from that standpoint, generation one goes from 600 to 1,000, right? So 1,000, the second generation doubled, be 2,000. Third, 4,000. The fourth to 8,000. The fifth to 16,000. And by the sixth generation, you're at 32,000 pounds, right? Now, six generations, I don't know how long cat generations are, but it's no doubt might be within my lifespan, or at least a human's lifespan. Um, you get to 32,000 pounds, which upon looking it up Indracotherium. I'm probably pronouncing the name wrong, but it's one of these big beasties that you get the the fossil evidence of a really gigantic mammal. It's has the record as the largest mammal ever to walk the earth. It was 40,000 pounds, 20 tons. 20 times 2,000. If I got it right, that's 40,000 pounds. So in 6 generations, then you can have a cat that's the size of the largest mammal at 32,000 pounds. Now, granted, it's 8,000 shy of it, but a cat that big would certainly be pretty impressive. And so if this was a process, then that uh, allows itself to extend this far, we don't know. We're kind of stretching the limits of the genetic. Maybe there's some wall the genetics puts in place. Maybe it's not all that easy to just keep doubling it. It's not a simple math thing or it trails off. If it goes the other way. Um, I find that interesting, just in terms of just getting things done. Again, looking at uh, not the effect of evolution on long scales. That's really what it's really just looking at it as a contradiction to that kind of thing. Um, so that the massive dinosaurs that we see, uh, if we took the math of their masses and worked backwards, we could find out how many generations with heterosis you can get these massive animals, and so maybe we get a lot of them really quick. Depending on how open, not knowing exactly which particular dinosaurs were uh, known to be able to actually be in the same family. We're making guesses on these things right now because there's no dinosaurs to interbreed. It just is an experimental bench. We have the ligers, which still exist, and we're getting this strange result. So it's just whether it's fanciful or not, I don't know. I just thought it was interesting to work that out. Uh, Subscribe. Trying to still get those subscribers because YouTube is kicking off everybody. But anyway, uh, and write a comment, send it to a friend or something. Anyway, well, that's all I got for this morning.